Okay, on part 2 here, we just learned that if the limit as x approaches c of f of x over g of x equals one of these indeterminate forms, then the limit of this equals the limit of the derivative of f over derivative of g. Alright, so let's go back to this one that we had stumbled on previously. And look at what this theorem allows us to do. It allows us, we tried this, came to a dead end, but we did notice it was 0 over 0. So that's one of the forms for which we can apply L'Hopital. So we can now take the derivative of this over the derivative of this and see if we can then take the limit as x approaches 0. So the derivative of e to the 2x minus 1 is e to the 2x times the derivative of 2x, which is 2, minus 0 over 1. Now can we take the limit of that? The limit as x approaches 0, e to the 0, which is 1, times 2. So it works. We found the limit, and whereas before we could not. And look how simple it was to do. Alright, let's try another one that qualifies. Let's say the limit as x approaches infinity. Doesn't have to, actually it can be infinity, so we can do ln of x over x. If you remember the graph of ln of x, or any log function, it crosses this point, has a tail here, and it goes up slowly, always increasing. Even though it's rising slowly, it is increasing forever. So what's happening as x approaches infinity to this value? Well, it's getting infinitely higher. So the limit of x as x goes to infinity, and the ln of x function is infinite. And as x approaches infinity, x is infinite. So there's one of our qualifying indeterminate forms that allows us to use L'Hopital. So we can say that this equals the limit as x approaches infinity of the derivative of ln of x, which is 1 over x, and over the derivative of x, which is 1. So now we can take the limit of 1 over x, and that is just 1 over infinity. And we know that as the denominator gets infinitely large and the numerator stays at a constant, then we are approaching 0. So 1 over infinity is 0. Alright, I'll leave one for you to try. And you can bring that in, put this in your comp book and give it a try. X squared, limit as x approaches negative infinity of x squared over e to the minus x. Alright, so try that one. You should get one of the indeterminate forms, and then continue using L'Hopital on the top by taking the derivative of the top over the bottom. But always check and see that it does qualify, and to make sure that when you put negative infinity in for x, you do get one of the 5 required indeterminate forms. Alright, so give that a try and we'll talk about it next time we meet. Alright, that's it for tonight. Over and out.